Sketch the graph of y equals negative a half tan of 2x plus pi on 3 for x is an element of negative pi to pi. Clearly label all asymptotes with their equations and axial intercepts with their coordinates. The first thing we're going to do is find the period of the tangent function. And the period is equal to pi divided by n, where n is the value that multiplies by the x, so in this case n equals 2. So that means our period is pi on 2. And the reason why we do that for tangent graphs is because every key feature is one period away from another one of that same key feature. So all of the x-intercepts are all pi on 2 apart, all of the asymptotes are pi on 2 apart. So now that we've found that, that'll be able to help us find all the information for this graph. So now we just need to find one particular feature and we'll be able to locate all of them. So we'll start off with the y-intercept, and we know the y-intercept occurs when x is equal to 0. So this will give y is equal to negative a half tan of 2 times 0 plus pi on 3 is just pi on 3. This is going to give y is equal to negative a half, and tan of pi on 3 is simply root 3. That's an exact value you should know. So that y value is going to be negative root 3 over 2. So that's the y-intercepts value. Next up, we're going to find one of the x-intercepts, and we know that this occurs when y equals 0. So that will give us the equation 0 is equal to negative a half tan of 2x plus pi on 3. And now we know that tan will equal 0 when the angle, or the bit inside this bracket, is equal to 0. So what we're going to solve to just find one of them is 2x plus pi on 3 is equal to 0. And now if we subtract pi on 3 from both sides, we'll have 2x is equal to minus pi on 3. And dividing both sides by 2 will give us x is equal to negative pi on 6. Now the reason why we only found one of these is because all others can be found by adding pi on 2 or subtracting pi on 2 from that. Another thing that we need to find for the tangent graph is the asymptotes. And these occur when cosine of our angle is equal to 0. And that's because tan is equal to the ratio of sine theta over cos theta. And whenever we divide by 0, we get a vertical asymptote. So this is just one way of locating the asymptotes. So we're going to solve cosine of 2x plus pi on 3 is equal to 0. And now we know that cos is equal to 0 when the angle is equal to pi on 2. So what we're going to solve instead is 2x plus pi on 3 is equal to pi on 2. So that's when our angle is at 90 degrees and it doesn't intersect the tangent line. So that's when we're going to get an asymptote. So to solve this, we can subtract pi on 3 from both sides, which will give us 2x is equal to pi on 6, and then dividing both sides by 2 will give us x is equal to pi on 12. So now we've got one asymptote and one x-intercept and the y-intercept, so we can start to find all the key features, keeping in mind that our period is equal to pi on 2. So the first thing I'd suggest drawing on when you're dealing with a tangent graph is the asymptotes. So this asymptote here that I'm just drawing on with a straight red dotted line is going to be x is equal to pi on 12. So that's the first asymptote we found. And now we can add on the period to find the next asymptote. And adding on the period is the same as adding on 6 pi on 12, just so we have a common denominator. So that will give x is equal to 7 pi on 12 as another asymptote. So that's going to be this straight vertical line through here. And then if we were to add another 6 pi on 12 onto that, we'd go to 13 pi on 12, which was greater than pi, so it's outside the domain. So we need to keep in mind that this is the domain we're sketching it over. So instead of adding on, we're going to subtract off. So we're going to subtract a period. So that will give us x is equal to minus 5 pi on 12 as our next asymptote. So that's this straight vertical line that I'm drawing in now. And then we can subtract one more period. and that will give us our final asymptote that is within this domain, and that's going to be x is equal to negative 11 pi over 12. So that's this vertical line right here. So because of this negative symbol here, our graph is actually reflected, which means it'll come from up here, inflect, and then go down here. And we found that this x-intercept was at negative pi on 6, and the y value would be 0. And we found that this y-intercept here was that x is 0 and y is minus root 3 on 2. So next we're going to put the same basic shape between each of the asymptotes. Now to find the coordinates of these x-intercepts here and here, and to find out if there are any others, we can once again just add or subtract off the period from this position. So if we add the period, that's the same as adding for this. I'm just going to add 3 pi on 6, so it has a common denominator. And now minus pi on 6 plus 3 pi on 6 is 2 pi on 6, and 2 pi on 6 is pi on 3, and that's going to be pi on 3 comma 0. And now we can in fact add on another period and still stay inside the domain. So this coordinate of the final x-intercept will be 2 pi on 6 plus 3 pi on 6 is 5 pi on 6, which is still less than pi, so that's inside the domain. So that means we've got another part of the graph that comes down through here, and it goes a little bit under the axes because it needs to reach 6 pi on 6 or pi. Now going backwards, we're going to subtract the period, which is the same as subtracting 3 pi on 6. So the coordinates of this will be minus pi on 6 minus 3 pi on 6 is minus 4 pi on 6, which we can write as minus 2 pi on 3 in simplest form. And the y value is 0, so that's the coordinate. And now if we were to subtract another 3 pi on 6 from that, we would go outside the domain. So there isn't any x-intercept on that side. So the absolute last thing to do is to find the coordinates of the endpoints of this graph. So the x value of this endpoint is negative pi. And if you think about it, that's exactly 2 periods in the negative x direction from the y-intercept. And if you go 2 periods backwards around the unit circle, you'll arrive at the same value. So this is going to be minus pi minus root 3 on 2 as the y value. And then over in the positive x direction, we'll have pi as the x value. And then once again, we'll have minus root 3 on 2 as the y value of that endpoint, because we're 2 periods on from the y-intercept. On this slide, a computer's been used to generate the same graph, and as you can see, all the same key features have been labelled on this as we found on the previous slide.